Hello, Professor. My name is Chintan Kavaria. Hope you're doing good. We're gonna go through the assignment two together. So let's just set up all everything. So I have uploaded my iris file CSV on the Google Drive as you said in the assignment and under the file here. So I'm just gonna go and look over all the questions. So over here it says upload the CSV into drive and find a path of CSV file and save it to the variable file name. So I just imported the PD, found the library as a PD and just need the actual path. So this is already says content drive. That's the content drive, my drive, assignment 2, and then iris. Just got the file name here. Next thing we're doing is reading the file like through the PD library CSV. So we'll get the data frame. And the whole CSV file is here in the iris folder. I am iris variable. The next one is show the first 5 rows. As we all know, like iris does had display the first 5 record of the data frame. So as you can see, those with the columns, and you'll see 0 to 4 index to 5. Next one is it's asking us to convert those should convert the last column which contains the string, and we want to convert the string to integer so we can work like as in your network model, right? So we're gonna use this method technology. Just select the last column, iris does pattern map, and the address is 0, color 1 and 2, and we're just gonna print again not only 5 is good. You'll see those spices were somewhere here on the string, so just convert to the zeros or the integers. So the first 4 columns of the data frame as data will call the data x. Okay, so we're just gonna use that location and select those 0 to 4, so 4 columns values. So this is a long data set. The next one is says select the last column as a label and call it y. We gonna do the -1 because in the Python -1's the last column, and just assign to the y. The next one is now it's a time to split the data x and y into training and testing segment and call them parts x and x test, y and y test, as we always do this. Okay, so we just imported the from SQL modern selection, and it's a split we also imported. So we just gonna assign the random stat and size 0.2, and it says for B please check the first 5 row extent. So we just gonna do 0.5 extend. You'll see the difference numbers here. Same for the x test, y chain, and y test. All of those numbers are the different. Check the length of the extent y test. If the number are 120 and 30, awesome, you're good to go. Okay, so we're just gonna check the length of it. Yeah, it is 120, so we're good. Next one is x test, it is 30, so we're good over here as well. And I'll just check the shape as well. So that's 124, so 4 column, right? And please convert the y and y into categorical and call them one hot trend label and one hot test label respectively. So we gonna do importing for slice transfer flow as utils, sorry, and import to categorical. So as we say here, one hot trend label equal to categorical y trend, and we're gonna assign the name y test to the one hot test labels. Okay, so it's a little big one. Please define a sequential model that consists 3 dense layer. In the first and second layers, use 100 hidden units and the rel activation function. For another last layer, we need to use the 3 as the number of output, and this is we have to 3 class systems, so 0, 1 as we know already. Also, please pick the appropriate activation function for the last layer. So we're gonna use the sort config as well for now, as you can see here. Just model sequential and adding those layers with density 100, and the last one as it says over here 3. So for the activation is software, and for those 2 is the relu. Now please compile your using rams prop unprepared loss function accuracy for your matrix. So we're just gonna compile rams prop loss category country matrix. We will use the accuracy, and just gonna do into 20 ports, so 20 cycles and 10 batch of 10. So as you can, I already run it, so I don't want to waste the time. So as you can see, all the ports is and we got the accuracy up 97 is going up gradually, and loss function decrease. So we just have to calculate the evaluate extra and one also accurate how model works. Okay, so we're just gonna calculate the accuracy here. So test loss, test and mode evaluate. Okay, so we're just gonna print the accuracy here, total loss and total accuracy. So accuracy with 90.96, and that loss was 0.14 something. It was good. And now we separate all the what we have done in 6 and in the first and second layers. Use the 10 units neurons and relocation. So we're just asking us to use specific relu and the 10 layers. So we're just gonna use it for like 10 dancer, and it's and the second one is use the same setting as you had done for the 6-bit comparison. So we're just gonna change the optimizer to the software, and lossless category is the same one. Tritium mode. So we just have ask us to do like 4 reports of 4 cycle only in batch of 10. So we batch size is 10, report 4, and the same thing. So it's going to be first calculate the result. So do the same thing we did over here. For yeah, there's one. We calculate the accuracy. So it's very low. Respectively, can't believe this. Just like 20. That was almost 96 something, 0.96 I mean. So it's a kind of from this you can say that if you have the less input cycle, the accuracy will be lower. So simplicity less breaking accuracy will increase with more hidden layers, but performance will decrease. Absolutely, right? But accuracy I mean not only depend on the number of layers. Accuracy will depend also on the quality of your model and quantity of your training data. Like with less input cycle, face the overfitting problem, but doesn't always happen. Yeah, but if the cycles are less, sure there will be less and reducing the accuracy. So 10B, we're gonna try the same thing again with a different. We're gonna change some parameters and like number of viewers and batch size and everything. We just gonna check the results. Okay, so 10B, what we did, what we changed in the major was the change. Epoch was 20. Last one was 10, I think. Oh, and 4, and then we first 20. And then we did batch size and 10. Just gonna test and evaluate it with the model test, print the same thing we did, okay? And here we go, we got the accuracy of 80.86, and loss score is also low. I mean, not that much, but it was 14 somewhere there. And it's good actually. It's a pretty good, yeah, relatively. So when we so I can say that when we increase the number of linear accuracy, increase for the variation digit. Then we just gonna change one more parameter, and that is epoch. Make it 5. So man, come on. Okay, yeah, make it 5. Test losses and doing the same thing. Accuracy again. You will see a massive change. 93. That means, as you can see, we did use the number of accuracy test will decrease since it, but this is good. But the loss function, I mean, the loss score is also high. So respectively, I can say that we increase the more hidden layers, performance will decrease for sure, but accuracy not only always depend on the number. It will also depend on the quality of and the data you fit and the training data. So I think so. We're just gonna submit here the assignment and link up this YouTube video. Thank you so much. Hope you like it. Have a good day.